So this is the 2022 Raspberry Pi Pico W, which is very similar to the 2020 Raspberry Pi Pico with one small addition, that rectangular shaped silver Wi-Fi module, which lets it talk over the internet. And today, I'm going to show you how we can use the Raspberry Pi Pico W with the DHT22 sensor to capture both temperature and humidity data and display that in a Power App Canvas app like you see here. So let's discuss the actual design for our solution. So obviously we wanted to take information collected from the Raspberry Pi Pico W and display that in a Power Apps Canvas app over here. But we have to follow a few steps in the middle to accomplish that. So first of all, we'll have the DHT22 sensor collecting both temperature and humidity data wired up to the Raspberry Pi Pico W through the GPIO pins like this. The Raspberry Pi Pico W has the RP2040 chip on board, and we can code with that chip through one of two languages, either C or C++, or the more crowd favorite MicroPython, which is a stripped down version of the full Python language. So we'll choose MicroPython. Now we want to store information in a SQL database. So we'll create an Azure function as our backend, which will have an HTTP trigger. And we'll have the Raspberry Pi Pico W, again, through MicroPython, make an HTTP request to our Azure function. And that Azure function will perform the query on the SQL database to store that collected information in SQL. Now, to surface that information in a Power App, remember a Canvas app requires information to be collected through a connector, and a connector requires information to be collected through an HTTP request. And also the connector requires information to be in the JSON format, JavaScript object notation. So we'll create another Azure function right here, which will again be an HTTP trigger. And the Power App, through a custom connector, will reach out to our Azure function, and the Azure function will perform the queries on SQL to collect the latest information from each sensor in the household. It will then structure that into a very specific format called JSON, and it'll be a simplified and very consumable format that then the Power App can consume and display that in a Canvas app. Okay, so here's the wiring diagram. You can see there are three connections to make between the DHT22 sensor and the Raspberry Pi Pico W. The DHT22 sensor can accept an input voltage between 3.3 and 6 volts. So we will hook up the positive terminal to the V bus or pin 40 of the Raspberry Pi Pico W, so it shares the same input as the USB. We'll of course hook up the ground pin, the negative terminal, to the ground pin on the Raspberry Pi Pico W, pin 38. And then the one in the middle, that out pin, is the data transmission line, and that will hook up to pin 34 or GP28, general purpose pin 28, and that will be what the Raspberry Pi Pico W uses to actually essentially read information, read data from the sensor. Here I am now soldering the DHT22 sensor directly to the Raspberry Pi Pico W with a soldering iron, but if your Pico W has header pins installed, you can also connect it with the female-to-female connectors. So I just finished soldering the DHT22 sensor onto my Raspberry Pi Pico through the GPIO pins. So now we're prepared to go into the software realm and actually start coding. And if you recall from the diagram I showed you before, the Raspberry Pi Pico W will actually upload data into a SQL database indirectly. It will do it through an Azure function. And so now, before we actually write the code in MicroPython that will run on the Raspberry Pi Pico W, we have to write the Azure function, the backend, if you will, that will accept information and data from this chip and then send it to an Azure SQL database. So here's the SQL table that I made to store data in our SQL database. I called it single value reading, and it has 5 columns in it. The first is the primary key, a GUID value that I called ID, capital I, lowercase d. The next is a field called collected at UTC, which is a date time value designed to hold the time and date that the reading was read from the sensor. Location is a tiny int or a byte value, and that's meant to represent which room in the home the reading came from. Value is a real or a floating point number, so it can contain decimal points, and that's meant to hold the actual reading, humidity, temperature, etc. And reading type is also a byte, a tiny int, which defines the reading type. 0 would be temperature, 1 would be humidity. So here I am actually in my VS Code code editor, and I'm in a new folder, and I'm going to create a folder within this project folder which will contain all of my individual repos which are part of this project. And I'll call that my source or my SRC folder. And within that, I'm going to have 2 code repositories. One to contain code that'll actually go on my Raspberry Pi Pico W, again written in Python. And another that will be the code behind my HTTP triggered Azure function written in .NET or C#. So first we're going to work on the C# Azure function. So I'll create another folder actually in my SRC folder, and I'll call that API. So with that API folder now open, I'm going to go here to my Azure extension in VS Code. Under Workspace, I'll click on New, or with the plus icon, Create Function, and I'll hit yes to this. I'll choose my language, which I use C#. That's my main language, so I'll choose C#. And then I'll choose the latest .NET 6.0. And I'll use the HTTP trigger as my template function. So my Azure function will rely on OData, or open data. And OData is simply a format that means that an HTTP endpoint will follow a commonly known format. For example, a GET request is to read data, a POST request is to post data or insert data into a database, delete is delete, and so forth. And so I want to implement the OData protocol or standard on my Azure HTTP function. And actually, I've made my own library to assist with doing that. You can add that to your .NET project by just simply typing into your console window .NET add package timhanowich.odata. And that will actually add the NuGet package to your project, which will allow you very easily to read from and parse an HTTP web request and essentially understand what the request is trying to do. I'm going to make a new file here in my project called odata.cs. And in here, I'm going to give it the same structure that you'd expect out of any C# class. Okay, so now I have the general structure for my HTTP Azure function endpoint. You'll see here I have a class called odata, and my function name is just called odata, and I call my actual method, my actual function in C# run. Here I'm declaring that the trigger is an HTTP trigger, so actual web request. It's an anonymous authentication. It can accept the post method, but if I wanted to add more to actually fulfill the entire OData standard, I could add here the get method, delete, put, etc. And here I define the route. So the route is basically what endpoint in my Azure function should it be hitting, or should it tie to. And here I'm saying the actual route to use my endpoint is going to be my API endpoint /odata, and then /, and in brackets here I have the word table, which means that that word there, that part of my route, will be dynamically filled in by the user. So in other words, I'm trying to capture that piece right here into this variable. So that can be any word or any table name, no matter what it is. This function will try to perform that operation on that table in this specific SQL database. So first of all, the Azure function will give me an HTTP request to use, but my OData NuGet package, my class library, expects an HTTP request message from the system.net namespace. So we're going to convert the HTTP request object into an HTTP request message object. So I'm going to do that right here. Okay, so now I have in the rec message body, or this variable, I have my HTTP request message. So now I'm going to actually attempt to convert my HTTP request message into an OData operation using my OData library. So I'll say OData operation op equals OData operation dot parse, and again it's going to ask me for the entire HTTP request message that I received. So I'll pass here into this function my rec message variable. And based on that, I want to do a few different things. Because obviously the procedure to follow will be different, whether it's a post request, in other words, insert data, or a read request, read data, or delete request to delete data, etc. And so I'm going to actually delineate what should happen based upon what the method was. So I'll say if the OData operation dot operation equals the data operation dot create. So again here, the operation types are either create, read, update, or delete. And I'm saying I'm trying to handle the scenario right now that would occur if the requester is trying to create data via a post request. So I'll say create, and I'll handle that here in this bracket. So the cool thing about my library is that with that HTTP request message, you're able to actually convert that HTTP request message into an actual SQL operation. So I'm gonna do that right here. So I'm gonna say string my SQL command, or my query, in this case an insert query, is going, I want that to be my operation.toSQL. And it'll ask me, for example, for the primary key name of the table for scenarios, we're like a delete operation, for example, where it's trying to select an individual record. But in this case, there does not need to be one, it's just an insert record. So I'm gonna actually leave that empty for now. So now I'll use the system.data.sql client namespace to perform that SQL query on my SQL database. So I'll say SQL connection, and this will be where I copy and paste in my SQL information. So I'll say SQL connection string here. I'm going to open my SQL connection, and I'm going to create my command. So SQL command is a new SQL command, and I want to execute my command in the string variable called SQL command on my now opened SQL connection. And now I'm going to execute. So I'll say await command dot execute non-query, and non-query just means that there's nothing that we expect to return from the database. So in other words, there's no response we should expect to get. We're just simply trying to send data off to the database. After that, I'm going to wrap up my operation. I'll say SQL connection.close to close off the connection now. And then I'm just going to return a HTTP OK response back to the user, back to the requester. So I'll say HTTP response message, response equals new message. Status code is going to be HTTP status code.OK, so 200 response. And I'll leave the body blank, and I'll just say return that response. So now we know that response will be returned for the create operation, but if this was not triggered, so for example, if the operation was a get request, or it was a delete or put request, we would handle those differently. But since I just right now want to focus on just the create request, I'm just going to say if they do anything else, just return a bad request response. Okay, so now I have my completed OData function. Here it is right here. So I am actually going to copy now into my project my SQL connection string, which of course I'll blur out. And that's essentially what is going to be used to connect to my SQL database directly. So now with that in there, I'm going to go back to my terminal with Control tilde, navigate to my API folder, and type in func, F-U-N-C, space host, space start. And that will actually compile my project and run my Azure function locally on my PC. So now it's telling me it found one Azure function endpoint, which is actually an HTTP trigger in my project, and it's called OData, and it correctly knows the path should have a slash with a table there. So I'm going to grab that URL, and I'm going to pull up Postman. And Postman lets me customize and edit my HTTP requests. So I'm going to paste that now into my URL. And again, change this from get to post, which means I'm trying to post data into the API. I'm going to change my table property there to the name of my table in SQL that should post to, which I called single value reading. And then for my body, which is basically my payload of information to post, I'm going to change that from none to raw. And the format of my body is not going to be text, it'll be JSON. And that's important because it'll now include a header in my request, which basically states that the body is in JSON format. So here I'm going to actually customize my JSON structure, my JSON object to send back to my API. So brackets, of course, they all have IDs, a separate GUID, which I'll post a new one in right here, right now. And then it also includes the location, room it belongs to in the house, which I'll just say is 99. And then it also includes collected at UTC, which is the UTC or Greenwich Mean Time of when it was collected, which again, I will post in just a random time right now. And then reading type, which states, is this a temperature reading or 0, or is it a humidity reading or 1? This is temperature in Fahrenheit. I'll do comma, and then the last one is the actual value itself to post, which I'll just say is 82.3 degrees Fahrenheit. So now I have my post method selected. I have my URL and my JSON encoded body. So I'll hit send to now test it out on my local computer here. And you see it responded back with a 200 OK response. In other words, it worked and it did properly execute the code here in my Azure function. So now this Azure function works correctly. We're now prepared to actually deploy this to the Azure function in the Azure cloud and actually query it there and not on my local machine here. So now I'm on the Azure portal, creating my new Azure function to deploy to. I now have my subscription selected and I have my resource group selected, gave it a name. For my runtime stack, I'm going to choose .NET, of course, C# Azure function. Version 6 is fine, region's fine, and that deploy to Windows is fine as well, and then leave it on the consumption plan. So I'll hit review and create, and I'll wait for the function to be made for me. Okay, so now my deployment's complete. I'm going to go to my resource now. And now that I actually have my Azure function made in Azure, I can go back to my VS Code window, under workspace, deploy to function app, select my subscription, and then find my newly made Azure function. So TAH Smart Home Demo right here. And I'll hit deploy. Okay, now my deployment is completed. So now I can go back to my Azure window again. I can go to the functions part of my Azure function. And this will now show me that I have one function there called OData. I can click on it. And it knows it's an HTTP request function. So it can actually give me the function URL, which is right here. So now instead I can take this, copy that to my clipboard, go back to Postman, and basically use the same test method from before, the same test request, and just substitute my local host URL with the Azure function URL. And of course, make sure you change the table portion of the URL to the single value reading. So now from here, I'm just going to hit again just to test it out, hit send with the same data. Actually, let's just change the GUID value so we know it's a different GUID. same location's fine, leave all the same, and then just hit send. And again, it responded back with a 200 OK response, so it properly worked. So now that information is now in our SQL database. So now that we have our API in the cloud, our Azure function, now we can create the code that will run on our Raspberry Pi Pico-W chip, collect data from the sensor, and upload that to our Azure function. And again, the RP2040 chip can run C++ and C, or MicroPython. And in this case, we're going to be choosing to use MicroPython, which is a stripped down version of Python. So here I am in my VS Code window. I'm going to make a new folder in my source folder, in my SRC folder, and that will contain the code in Python or MicroPython that will run on my Pico-W. So I'll choose the source folder, new folder, and I'll just call this RPI for Raspberry Pi. So first of all, the main script that will actually facilitate the data collection and upload process needs a few things to rely on. So I'm going to create a new module or a new file in my RPI folder, and I'll call that toolkit.py. And I'm going to have you just simply copy and paste this code into this folder and then save it. And again, all of the code here will be available on GitHub after this video is made. So now with my toolkit.py file saved, I can close out of that now and make another script in my RPI folder that I'll call main.py. And we call it that because when you provide power to the Pico-W, it'll automatically search for a file called the main.py, and that will be essentially the entry point for your application. So all of my code that runs here that does the data collection and upload will go in this file. So the first thing that we want to do, if you remember, is use the onboard Wi-Fi module to connect to our internet access point, our local network. So I'm going to do that right here. So here's my code for connecting to the Wi-Fi access point. It uses the SSID here, the access point name, and the password to connect. It waits a moment, and then based upon whether it was successful or not, it prints a message, and if it was successful, it continues on. If not, it tries again. So luckily for us, MicroPython has a DHT22 sensor reading module built into it, and we can use that here. And of course, we're mapping it to our pin 28, or GPO, I should say GPO 28, and pin 34 on our Raspberry Pi Pico-W. And it's meant to be an input pin. In other words, it's meant to read data coming in from the sensor, not out. So now that we have the network connected and sensor prepared to read data, now we'll create our continuous loop, which will read data, then post that to our Azure function. Okay, so now I have the infinite loop that does the read, collection, and upload to our Azure function right now. So first of all, we are importing a few different modules that we'll need as part of this loop. The first is uRequests, which is the MicroPython equivalent of the request library from Python. Allows us to facilitate HTTP requests. And then also from before, we have the toolkit, and we'll use a few different parts of this toolkit in this loop, which you'll see here in a moment. So the first thing that we're doing here is reading data from the sensor. You'll note that sometimes in testing, the sensor might not be very reliable. It might return bad data to you. So we're actually performing that read continuously until we have data for both temperature and humidity. The DHT22 sensor provides data to the chip in Celsius natively, but I want to store it in SQL in Fahrenheit. So I'm doing the conversion from Celsius to Fahrenheit right here. I'm then printing that out to the console, the data that we have, both temperature and humidity. And now I'm preparing to make my HTTP post request to my Azure function with that data. And I need a few things as part of these post requests. I first of all need the current UTC time, and I need the URL that it'll actually post to. So put your Azure Functions HTTP triggered URL endpoint right here. So beneath that, we're now going to be constructing and posting our HTTP request to our Azure function. Firstly, I'm doing temperature, and I'm constructing the body to be posted right here. I'm inserting a new ID, a new GUID value. I'm tagging the date and time it was collected at, its location, which you might want to have a different ID number for each room in the house, for example. Reading type is either going to be 0 for temperature or 1 for humidity. So I have 0 for temperature, obviously. And then the value itself is going to be the temperature reading in Fahrenheit we captured before. And then I'm using this variable here, TPR, which just means temperature post request, my acronym for that. And I'm using the uRequest module to post to this URL up here. And I'm specifying that I want my body to be a JSON object, and I'm plugging in my constructed JSON body here. And then after it's requested to the endpoint, I'm then closing the connection with the Azure function here. And then I'm closing the connection to the function. And same thing for humidity. Instead here, the only difference is the reading type will be 1, and the value will be the humidity variable we captured before. And then after both uploads, we then want to have our program wait before reading and uploading again. I want to have my program upload once per minute, so I'm choosing to have my program here wait a full minute or 60 seconds. So before sending my scripts to the Raspberry Pi Pico, I'm going to enter in my Wi-Fi information. So to flash the Raspberry Pi Pico W, just connect your Pico W with a USB to your PC. So now with my Raspberry Pi Pico W connected, I can use R shell, a Python library, to flash my code onto the Pi Pico W's memory. So now I'm using R shell, and I can choose to navigate to my Pi board, or the onboard storage of my Pi Pico W. I can use the command ls to see what's actually in storage here. It's a new chip, it's a new Pi Pico W, so it's empty. And I'm now going to copy my code files from my PC storage, my hard drive storage, onto my Pi Pico W. So here's the command for doing that. I'm using the command copy to copy files. I'm saying copy files from my RPI folder here. The star means copy all files in this folder, and I'm copying them to my target, which is the Pi board or the Raspberry Pi Pico W's memory. And you'll see now that 2 files have been copied, and again, one of them is called main.py, so we're assured as soon as the Raspberry Pi Pico W gets power from a USB source, it'll execute that script. And with that, I'll now close out of R shell by just using Control-C on my keyboard. As I said before, automatically that main.py file will start running when it's plugged into a power source, or I can manually invoke it here with CoolTerm from my PC environment. So I'll connect now to my Raspberry Pi Pico. This is a REPL, a read, evaluate, print, loop interface. So I can very easily enter in some MicroPython code to run here. For example, I'll say print hi, x equals 2, y equals 3, x plus y. It'll print the answer for me. But I'm going to tell it to run my main script. And to do that in Python or MicroPython, you just use the word import and then the module name after it. So I'll say import, and then main is my module. So I'll hit enter. You see here now that it did connect to the Wi-Fi successfully. It read data from the sensor. It captured both temperature and humidity, printed it out here, and then uploaded those to my Azure function through an HTTP post request. Now it should wait for 1 minute and then proceed to do the same thing again. Okay, now it's reading, it captured the information, it's uploading both temperature and humidity again, and then it'll wait again, and that loop will continue indefinitely. So now that I saw that my code works in this REPL environment here, I'm now going to disconnect, unplug it from my computer, plug it into a wall through a USB connection, and then let it run independently. I want to show one more quick thing here too. Right now I'm in SSMS connected to my Azure SQL database, and as I refresh my records, you'll see a constant stream of new data coming in from my POW. Just shows it's working properly. So now with my data in SQL, now I want to create a way for me to consume and show it in my Power App. Power Apps and Power Automate use connectors to connect to external data sources. In this case, we're going to create a custom connector and point that custom connector at our unique Azure function endpoint and teach it essentially the schema and the way to read from our API. So from here, I have two options. I can go back to my Azure function and further develop out my OData endpoint. Add an ability, for example, to read data using a GET request. But if I did that, I would be delegating all the logic to the Power App. Instead, what I want to do is contain that logic into an Azure function, a new Azure function, and in .NET write the logic that will go through for each room in the house, find the latest temperature, humidity data, and then encode that in a very specific JSON format and return that back to the requester. So for multiple reasons, but mostly the complexity of this operation being better suited for a traditional coding environment like .NET, for example, probably not PowerFX and Power Apps, I'm going to create a new Azure function endpoint. It'll also be HTTP triggered, and this endpoint is going to go through and do the operation of gathering the latest temperature data, humidity data from each sensor in the household and formatting that into a standard view that you'll see here and consume in the Power App. So here I am now in my VS Code window, back into my API folder. I'm not going to live code this endpoint. It's rather complicated, but I'll go through it and explain to you how it works. You'll probably see two additions here, the single value reading and snapshot files. And I'll start first with the single value reading class. So this is a class designed to be a one-to-one mirror or one-to-one pairing with the single value reading table in SQL. We have the same properties here from SQL, the GUID value, date and time, location, value, and reading type. And below that, I just have a few different static methods designed to deserialize from JSON. Now moving to my snapshot file, this is where I house the snapshot endpoint for my Azure function. So all the logic that runs the snapshot function will be in this file here. Now here's the function itself, but if I scroll down, I first want to explain to you the way this will work. So what will happen here is the Azure function will search through the last 1 hour worth of data in my SQL database, and it will look for distinct locations in that hour. In other words, if I had 3 sensors in the household, it would find those 3 sensors are locations 2, 4, and 7, for example. And then after doing that, it will structure that data into a JSON array or a J array in C# and return that back to the requester. So scrolling up now to my snapshot Azure function, here I am gathering the distinct locations for the last 1 hour worth of data. I'm looping through each of them here, and I'm gathering for each location the latest temperature data and the latest humidity data. I then create a new JObject or a JSON object, and I structure that with the location first as a property, and then I'm entering into that JSON object the temperature and when that was collected, and humidity and when that was collected. I then add that or append that to the list, and that list will ultimately become what we return back to the requester, and we return that back in JSON format. One more thing, if you are using this code file, just be sure that you replace this parameter here with your SQL connection string. So now with my snapshot function complete, same as before, I'm going to pull up my PowerShell module in VS Code with Control-tilde. I will navigate to my API folder. So I'll first go through source, then to the API folder itself. And then I will enter in here the command to locally start my Azure function, func post start. I press enter to compile and run my function locally. You can see here now, the same as before, it found an Azure function, but this time it actually found 2 endpoints to run, and I'm going to copy and paste this snapshot endpoint. And before I use Postman to facilitate the post request to the OData endpoint, but in this case, this endpoint is only a GET request endpoint. In other words, I can use that in a browser. So I'll pull up a new browser session here, and I will paste this into my URL, press enter, and locally the Azure function endpoint will perform that code and return back to me my JSON response. Again, what it did here was look for the distinct locations in SQL for the last 1 hour worth of data. It then, for each location, found the latest reading for temperature and humidity and compiled that into this format you see here. So now that I ensured my Azure function runs properly locally, I'm prepared to deploy it to the Azure cloud. So I'll go to my Azure add-in. For Workspace, I'll choose to deploy to a function app, choose my subscription, and then find my Azure function to deploy to. All right, so my Azure function has now deployed to the Azure cloud. I can open it up in the Azure portal here, go to the functions pane, and see a list of my functions and their trigger. Both are HTTP in this case. Click on my new snapshot function. I can pull up the snapshot function URL endpoint. Again, it's a GET request function, so I can just pull up a new tab in my browser, paste that in, hit enter, and confirm that my function is now working in the Azure cloud. So with my snapshot function now working, I'm prepared to go into Power Apps and create the medium that we'll use to transact with this endpoint. And in Power Apps and Power Automate, we call that a custom connector. Here I am in my Power Apps environment. On the left, I will expand the Dataverse tab, and I'll click on Custom Connectors. At the top right, I'll click on New Custom Connector, and I'll click Create from Blank, give it a name. I'll call mine Smart Home. And for the scheme, I'll choose HTTPS. Every Azure function natively supports HTTPS and HTTP. For the host, I'll go back to my endpoint and copy and paste this portion of the URL. I'll go to security. Here is where you would specify if there's, for example, an API key that you would use or OAuth to use, but in this case, my function is open to the public. It's anonymous. So I'll go to definition, and in definition, this is where I would specify the individual endpoints available in this API. So I'll just add one for right now. I'm going to add the snapshot endpoint. So for summary, I'll just call it snapshot. And operation ID, it needs a capital starting letter, so I'll say snapshot with a capital S. So this connector also needs to know what the URL endpoint to hit is and what method to use, headers to include, body, etc. to use. And so we're going to tell it that by importing from sample. So I'll click here on import from sample. I'll select my request verb type, whether it's get, delete, post, etc. Mine is a get request, and I will paste in the full URL to my endpoint and click on import. Now, if there were any headers, parameters, or body that goes into my request, they would be parameterized here. The custom connector also wants to see an example response body from the API. So I'm going to click here on add default response, and it'll ask me to copy and paste in an example body. I'll go back to my endpoint I tested from before and just copy and paste this full response into this window. And then click on import. So now I have my snapshot action defined in my custom connector. So I'm prepared to create my connector. At the top right, I'll click on create connector to save my work. And now with my custom connector made, I can go to the test tab and click on test operation to test my custom connector action. I'm going to go and create a new application. So from the home tab, I'll click on blank app, and I want a blank canvas app. I'll take the phone format, and my app name will be Smart Home Monitor. Hit create, and this will create my new Power Apps canvas app for me. So firstly, I want to establish a connection to my custom connector in my Power App. So then on the left, I'll go to the data tab. I'll click on add data, and I will search for my custom connector that I called Smart Home. There it is. I'll click on it, choose my current connection to it. So now I'm able to call the endpoints or the actions in that custom connector from within my Power App. So at the top, I'll put a label for my app. And in the top left, I want to have an icon that will be my refresh data button. So I'll insert an icon, and I want this to be a refresh icon or reload icon. For the onSelect property of this icon, I'm going to enter in the formula set a variable called myData equal to smart home, my custom connector, dot snapshot. And again, this endpoint or this action does not have parameters in it, but if it did, I would specify them here. So from here, I'll also at the top right hit play and click on that icon to pull data into that variable. And now with data in that variable, I want to display that in a gallery, which is in Power Apps a way to show a series of records or items. So at the top, I'll go to Insert, Layout, and I'll choose a blank vertical gallery. And I'll make this the entire size of the remaining screen. And for items, in other words, what should the gallery show? I'm going to say I want it to display the array or the list of records, my data. And to customize what's shown on each row of this gallery, I select the first row and then insert different text labels, images, whatever it might be, to display data in each record. So for example, at the top, I'll click on Insert and I'll say Text Label. And at the very top, I can reference this item and then a period, and this will pull in the parameters from before that it learned are contained in the JSON body. So for example, I can say temperature for each room. I can insert another one and say this item dot humidity to show humidity for each room. On my PC here, I also have a few images I want to represent each record or each location in my gallery. I have a couch for my living room, a bed for my master bedroom, a garage, of course, for my garage, and some beakers for my test location, location 99. So to add those pictures to my Power App, I'll select the first row in my gallery. At the top, go to Insert, and under Media, I'll select Image. And that'll put an image in the first row, which again will propagate down and copy that for each row after this. And for image, I'm going to add an image file. And I'm going to add all 4 of my images you saw before. But now I want to dynamically show the image that relates to or corresponds to this record. So at the top in the image property, I'm going to add in some PowerFX code to do just that. I'm going to say, if this item or this row, this record, dot location, and remember location is the ID number of our room in the house. If it equals 4, which in my case is my living room, I want to show the couch icon. This would typically be the else value, but you can also use another if statement or a conditional statement to serve as another if statement. So now I'll say, if this item dot location is 5, which is my master bedroom, show the bed image. If this item dot location equals 7, which is my garage, then show private garage. And if this item dot location is 99, my test location for test data, I want to show the Flask image. Okay, so now I am conditionally showing the picture that corresponds to each individual record. And now I'll just format the way I want it to show my temperature and humidity data. So below the data points, I want to include a label that shows the elapsed time since the data was collected. The challenge here is in each record, the collected at time is in a UTC format, not my current time zone. So in Power Apps, I would have to determine the UTC time and then compare that to the collected at time to determine how long ago that was collected. And I'm going to use a function here called dateAdd, which will allow me to add to my current time the difference between my time zone and the UTC time. So I'll say dateAdd. I want to add to my current time the number of hours, so I'll use the time zone offset function, and I want to get the offset between, again, my current time zone and the UTC time, and I want to gather that in minutes. So now I have my UTC date and time stored in a variable called UTC date time. So now going back to my gallery, if I select my time elapsed here label, I'm going to change my text to show me the number of elapsed seconds since that data was collected. So going back now to my gallery, I have my label selected, and I'm going to use the date diff function, and this will calculate the difference between two date time values. And I want to compare the time this item was collected, so temperature collected, which again is a UTC time, and my current UTC date and time, which I stored in my UTC date time variable, and I want the difference in seconds. And then I will say I will append to my time difference seconds ago. And now if I refresh, you'll see it will show me elapsed time since data collection. So now with my app completed, at the top, I'll click on Save. I'm going to save my app as Smart Home Monitor. And after save, I'll click on Publish. And now going back to my Power Apps Maker portal, if I go to Apps, I can see my Smart Home Monitor app. I can play that. And from the play mode, I can refresh and see all the data shown to me. That's live data.